This is Unit 2. We are going to go through one of each of the topics in this video, and I'm hoping to get all of the topics done in one video, but we'll see how it goes. It might not be. It might have to be split up into a couple different videos. So, for each ordered pair, determine whether it is a solution to 2x plus 7y equals negative 5. Now, if you're not sure, I've got the topics written on the bottom of each slide. So if you're going to fast forward, you can look for those as well. Otherwise, you can look through the scroll bar. But this is topic number 1. So to do this, we are going to basically just have to plug things in. So I've got 2 examples shown. I didn't do all of the examples because they're all exactly the same. But as you can see, I have it in a different color inside for those points that I plugged in. So in for the first one, x, I plugged in a negative 5. In for the y value, I plugged in a negative 4. But yeah, after that, it's just solving the equation to see if it works. Now, at the end here, I got negative 38 equals negative 5. That's obviously not true. So that would be not a solution. That's why I put no for that one. When I plugged in negative 6, positive 1, though, like right here and right here, I plugged them in. It turned out to get me negative 5 equals negative 5, which is a true statement. So that's why I put yes for that one. So you're just plugging in the other ones just like I did. Pause the video, use my template, and you'll be able to solve those. Topic number 2. Find an ordered pair xy that is a solution to the equation. So right now they gave us an equation. They want any solution. So basically what we're going to do here is we're going to basically say, okay, let's just pick x or y and make it 0. Because if we make it 0, like I did here, let's just assume x is 0, then we can figure out what y is. So to do that, if I plug in 0 for x, whoops, I didn't mean to do that, sorry. If I plug in 0 for x like that, I get a 0 that I'd plug in there. I could solve for y, which I ended up solving, and I got y equals negative 4. You can stop the video and check my work. I think it's negative 4. So my final answer there would be 0, negative 4, because I'm still plugging in a 0 for my x. My y just turns out to be a negative 4. Now in this problem, you could also just plug in a 0 for y, so you could set it up like this, where we don't know what x is, but we plug in 0 for y. If I wanted to do that, all I would have to do is plug in a 0 for that y, solve for x. That's going to work too. It's going to give you a different point, but plugging in 0 for either of them. You can honestly plug in whatever number you want, though. I could plug in a 2, a 7, a 223, whatever number I wanted. So let's just say I wanted y to be 17, for example. That's fine. I would just plug a 17 in there, and I would solve. I'm only choosing zeros because zeros are easy to work with. So that's why I use zeros, and you should probably use zeros too. It's just easier. Graph the line. Topic number 3. I've already got it graphed for us here, but if I'm graphing this line, I need to look at 2 things. First of all, my negative 7 there, that's my y-intercept. That's step 1. I have it listed right there. Step 1 is that point. Put that on your y-intercept at negative 7. Then I'm using my slope. It's not 2x, I guess. It's just the 2. My slope is the 2, which means it's the same thing as 2 over 1. So I would rise 2, run 1, rise 2, run 1, rise 2, run 1. And that's how I graphed this line. Topic number 4. Oops. Topic number 4, we're graphing this line. This is no different. Our first step is still to plot that 5 on your y-axis. Our slope is just a little bit different this time. It's negative 1/4. So I'm just going down 1, down 1 over 4, down 1 over 4, down 1. It would be over 4, but it's off the graph. And then I went the other way too. I went up 4 and backward, or up 1 and backwards 4, up 1 and backwards 4. So that's how you graph that one. Number 5 says graph the line x equals 5. The best way I can explain this is basically draw a line that's going through the x-axis. It's going to be a perfectly vertical line on this one, and I chose to do vertical because if you look at every single one of the points that are on this line, this is the best way to do this. You can pick any point where the x value is equal to 5. So this point, the x value is equal to 5. This point and this point, they're all equal to 5. So if you pick any 2 points with an x value of 5, they're all going to be ending up in a vertical line like you can see here. So yeah, that's how you would draw your line. Another way to remember that is it's going through the x-axis at 5, right? So that's why it's x equals 5. Next one. The equation of a line is given below. Okay, so it gave us this equation. It says find the x and y intercepts, then use them to graph the line. Okay, so this one can be kind of tricky. So if I'm finding my x and y intercepts, the one thing that I have to kind of look out for here is, well, what are those points going to look like? If I come over to my graph, I've already got it graphed, I know, but I'm going to show you here how I came up with it. This point right there is -2, 0. This point down here is 0, -4. Okay, those are my 2 points. So the one thing that they have in common is that they both have a 0. So basically what I'm saying here is if I plugged a 0 in to find this point, if I plugged in a 0 for y, I should get -2 out because that's the x coordinate there. So if I plug in a 0 for y, basically what that's going to do is 3 times 0 is 0. It's basically going to get rid of all this stuff. We'll just be left with 6x equals -12, which is what I have drawn down here. Okay, let's say I plugged in a 0 for x. As soon as my screen catches up, if I plug in a 0 for x, we have 3y equals -12. That's my other one. So after I solved those, them, like for this one, I got x equals -2, and this one I got y equals -4. Those are my intercepts. This is called intercept form for a reason. This right here, you might want to write that down in your note guide. This one is, oh, I'm sorry, it's not intercept form. It's standard form. That's my fault. Standard form. Okay, so we have standard form. We're going to find our x and y intercepts using these 2 things. So basically just coming from plugging in a 0 there would cancel that one out, and plugging in a 0 there would cancel this one out. And these are the 2 equations that you're left with. Then once you solve for them, x equals -2 means my intercept on the x-axis will be at -2. And my intercept on the y-axis is at -4 coming from this one. So those are my 2 intercepts. And then after that, Alex, is pretty simple. You just need 2 points to be able to draw your line between them. Next one, the equation of a line is given below. Okay, they gave us the equation again. I added 8 to both sides to start because I'm trying to graph them, right? And it's asking us for the slope and the y-intercept. Otherwise, I guess I could use the same strategy that I used in our last topic. But I want my slope and my y-intercept, so I'm going to do slope-intercept form, which is y equals mx plus b. That's my slope-intercept form. That's going to give me my slope and my y-intercept. So to do that, you're just basically solving for y. So I took this equation, I solved for y, and it took me down to here. You can check my steps to see if I got them right. I did get them right, I think. So then my slope would be -4 and my y-intercept would be -1. And then we're just graphing the same way we've been graphing. Plot your y-intercept first, then use your line. You're going to go down 4 over 1, down 4 over 1. Topic number 8. A line passes through the point 10, -7 and has a slope of -3 over 2. Write an equation in slope-intercept form for this line. Okay, this is kind of a tricky one. we're kind of changing it up on us a little bit here. So for topic 8, the number one thing that you need to have on your note guide is this equation right there. This equation is called point slope form. Oops. Point slope form. What do we have in point slope form? Well, the m, we all know, is the slope, right? That's an important part. The other part is a point that we are going to write in. We're going to fill in that x1 and that y1. Everything else kind of just comes down in this part of the equation. So with what we have up here, since they gave us a point and a slope, I think point slope form would be the best form to use. So what we're going to do is we're going to fill in what we know. We filled in y1 with a -7. We filled in our x1 with that 10. So those are just coming from up top. And then we start to solve. So we get, we're going to make this a +7 because we had two negatives. And then I distribute that 3 halves to get, that -3 halves to get -3 halves x minus 15. Subtract 7 from both sides. And this is our final equation in slope-intercept form. It did want that in slope-intercept form. That's why we ended up changing it. If it didn't ask for slope-intercept form, though, you could honestly be done with the problem at like this step. That's in an equation form. And on the next topic that we do, topic number 9, that's where we can stop, actually. So let's do topic number 9 now. Okay, topic number 9 is interesting on ALEKS. Reason being, it gives it to you in two different ways. So first of all, it gives us a graph like you can see here. That's one example. The other example, it could just give you the 2 points like as an ordered pair. So instead of a graph, it would just put like, for this one, for example, it would be -1, +1. Oops, let me change to, there we go. -1, +1 is one of the points. The other point is at 3, 3. Okay, that's where my 2 points are. We can't probably just look at the graph to make an equation because of this right there. That's halfway on this one. It's not always going to be exactly halfway, and it is going to end up being halfway here, but I believe it is. Maybe I did something wrong in my work. It is supposed to be 1/2. I don't know. I must have done something wrong. We'll check it here in a bit. But anyway, I would use the same formula that we used on topic number 8, that point slope form formula. This one right there, that's an important formula. And I've got it written here as well. It's right there, point slope form. That's going to be the best way to solve this. So what do we need for that form? We need 2 things. We need a slope and a point, and we have both of those. I found the slope by doing rise over run, so if I rise 1 and run 2, that's going to be the slope for this, rise 1, run 2. That's my slope. My point, I could basically pick whatever point I want. I picked the easier one. I think it's easier because they're both positive. Then I've got my point slope form, and all I need to do is fill in the pieces. So I filled in y minus 3 for the first part, and then I filled in, so I put my slope in there, and then I did x minus 3 as well. And that's where I seem to have went wrong, maybe. No? I don't know. Oh, -3 halves plus 3. That's where I went wrong. Okay, so I just messed up this last little piece. -3 halves plus 3 is a +3 halves. That looks better. This is at 1.5, which is the same thing as +3 halves. Okay, now here's the most important part. On ALEKS, if you use point slope form, you're going to be rewarded here because technically you could be done at this step. I just showed the rest of the work. In case it were to ever ask you, put it in intercept form. Everything below my highlight there is what you would do, but you're not going to have to do any of that on ALEKS for this topic. It's done. This is what I've highlighted here is technically an equation, and all ALEKS is asking for is any equation. It's not asking for a specific type of equation. It just wants any one. And so that's the equation that I would use if I was typing it into ALEKS. Moving on to topic number 10. Okay, this one's kind of a quick and easy topic. It says write the equations for the vertical and horizontal lines passing through the point 2, 0. So if I were to draw this out really quick, let's go here. 1, 2, 2 is located right there. 2, 0, that's that point. If I wanted to do a vertical line, that would be like this. That vertical line is going through the x-axis at 2, and that's my equation for it. If I wanted to do a horizontal line, I'll use a different color here because it's going to be kind of tough to see. My horizontal line is going through right there. That's going through the point. Now, what's the height of that line? It's going through the y-axis at 0. So that's my point. Why is this so quick and easy? Well, you start to figure out after a couple of these that you can just look at your point to find out what it's going to be. So, for example, my x value of that point, x equaled 2, and my y value of that point, my y equaled 0. It's that easy to get to the answers. X equals 2 and y equals 0. So that one should go quick for you. Consider the line y equals negative 1/5 x plus 7. It first of all wants to know the slope of a line parallel to the line. Lines that are parallel have the same slope. So it would be a negative 1/5 because that's what this slope was. Perpendicular slopes are a little bit different. A perpendicular slope is the opposite reciprocal, meaning I'm going to flip this fraction upside down and make it a positive. And if I do that, I'll just get a positive 5. So I flipped the fraction upside down, so it was 5 over 1, and then made it positive. So it ended up being a positive 5. Topic number 12. The equations of 3 lines are given below. Here are my 3 equations. It says for each pair of lines, determine whether they are parallel, perpendicular, or neither. Now I took those equations. Let me show you what I did here. I looked at them, and line 1 was already in slope-intercept form. I like slope-intercept form for these because slope-intercept form shows me the most important thing that I need here, which is my slope, negative 5 over 2. Line 2 does not show me my slope, so I had to draw it over here and go through and actually solve it for y. After I solved it for y, I got 2/5. You are going to have to pause the video and write that down and then make sure that I did everything right. But I just basically solved for y up in that black bubble up there. So I got 2/5. Looks to me like that's going to be an opposite reciprocal, but we'll come back to that in just a second. I did the same thing with this one. I showed that, well, first of all, I solved it, and then solved it for y, and then I got negative 2/5 for my y-intercept. Or sorry, not my y-intercept, my slope, sorry. So my 3 slopes are highlighted on the screen right now. Line 1 and line 2 look like opposite reciprocals. Line 3 does not look like it matches anything. So I wrote them all right here. These are all my slopes that I got from doing those problems. And I showed that the first 2 are perpendicular. And I think that's all you have to write down for ALEKS. Somehow you're going to have to write lines 1 and 2 are perpendicular. So that's topic 12. Topic number 13, we've seen this before in this video. That's your point-slope form equation. This problem is really easy if you use point-slope form. It's not very easy if you don't use point-slope form, if you use any other form. So I'm only showing it in point-slope form. I want you guys to use it this way. So it says, here's your slope. I need you to find the equation of a line that's parallel and goes through this point. Well, with point-slope form, that's pretty easy because this would be parallel. 6 over 5 is parallel. And the point, I just plug in 4 and 6 from over here. A perpendicular line, I'm setting it up the same way. I still use 4 and 6 because that's what it wants. And then my slope is just an opposite reciprocal, so I'm going to flip to negative 5 over 6. And that's my full equation. I just flipped that fraction upside down and made it the opposite. Topic number 14, we are going to determine whether these are functions or not. The main thing that we need to understand about functions is that every input or domain in this case, it's the same thing as input if you wanted to write that down. Every input has exactly one output. So, do these all have exactly one output? Yes, pen does. Oh, I'm going to change that actually so I can show it better. Pen has exactly one output. Tree has exactly one output. Lake has exactly one output. Pepper has exactly one output. This is a function. Number 2, do they all have exactly one output? Yes, 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 and yes. Now, does it matter that 0 has 2 things pointed at it? The answer is no, it does not matter. The outputs can have more than one coming at it. We just have to be certain that everything has one arrow coming out of it. So this would be an example of something that isn't true. Because 2 has more than one output. It has an output to A and it also has an output to B. So let's think about it in a different way. If we had ordered pairs instead, the first one is going to be like your inputs or your domains. These are your domains. And it's okay to have a domain listed twice. It's just not okay to have it having different outputs. So for example, G here has an output of B and H. That is where we're going wrong. So that's going to be not a function. Also, W and G can't both be outputs for B. Relation number 4. So all I'm basically looking for here is, do I have 2 of the same inputs? The answer is yes, I've got negative 4 listed twice. It's okay if they have the same output, but in this case, they don't have the same output. One's a V and one's a Y, so this is not a function. Topic number 15 is going to go kind of quick. It wants to know if these represent a function. We are going to use the vertical line test to determine that. My vertical line test is basically drawing a vertical line through a graph. If it can touch somewhere more than once, this is not a function. There's me drawing a vertical line through the first one. That's not a function. Drawing vertical lines through this one. I can draw it everywhere on here, but only hit once if they're completely vertical. So this one is a function. Let's look at this one really quick. Is there any way that I can draw a line and have it hit 2 dots? I don't think so. I'm not very good at drawing perfectly vertical lines either. There we go. Looks like this one works. Even if I extended this all the way down, it wouldn't hit another dot. This one here. Oh, I hit twice, once there and once there. How about this one? Looks good. Looks good. Looks good. Oh, no. That one doesn't work. And then our last one here. I've hit twice. I've hit right there and right here. So this is a no. Now let me explain to you. If you see one of these on a homework problem, I just wanted to show this. If I were to draw a perfectly vertical line through this white dot, that open circle, and the other line, that would be okay. I mean, it's not okay for this problem because of all this, obviously. Like, that's multiple times. But if I had it go like closed circle to an open circle, and then on the bottom of that open circle, there was a closed circle going this way, and maybe another open circle, who knows? Right here, that's really only touching once because that open circle doesn't really apply to this problem. Okay, moving on to topic number 16. So we're just finding domain and range here. So domain, like I said in the previous topics, those are going to be your inputs. So my domains, they want this written in set notation here. This is the problem. So my inputs would be 6, 1, and negative 5. I'm going to put them in numerical order. I don't think Alex requires it, but I'm going to do it anyway. 5, 1, and 6. My outputs, or range, would be negative 9. Ooh, I see 2 negative 9s there, though. We don't have to list them twice. If you see the same thing twice, you just would list it once. And 0. Ooh, I must have deleted 1 on accident. 6, sorry. So that's your final answer for topic number 16. Okay, next one, topic number 17. Ahmed receives a $50 gift card for a photo center. He uses to buy prints that cost 8 cents each. The remaining balance B in dollars on the card after buying X prints is given by the following function. So this is our function. X, it says, is the remaining, no, I'm sorry, B is the remaining balance. X is the number of prints that he's buying. So he's buying 40 prints. All I have to do is plug in that 40 for X. This should be pretty simple. I got 46.8 after I plugged it in. Okay, the entire graph of the function g is shown in the following figure. Write the domain and range. Now we're going to get a little bit more complicated here with domain and range because we have open circles and closed circles. We're using interval notation. And this graph is one that we might not have worked with before. My domain, this is something you should write down. My domain is all of my x values. My range is all of my y values. These are all of the possible x values that you can see and all of the possible y values you can see. If I'm thinking about my x values, I'm thinking about the x-axis. So I see my line going everywhere from -3 to 4 on the x-axis. There isn't anything outside of this. So if I was able to draw this, everything is contained within those x values. So how would I write that out? Well, this one here, this contain is an open circle. So I would have to use my parentheses for that. This one over here is a closed circle, so I would use my brackets for that one. Same thing with range. Now if we're talking about range, I'm going to show you by highlighting my y-axis. Everything from 5 down to -5 looks like it's included, because if I were to show you by drawing lines, it would be everything in between that range. Okay, so if that's my range, if I look at the bottom end, because that's the low part of my interval notation, that's a closed circle. So that's why I have that bracket. And if I look at the top end, that's an open circle. So that's why I have that parenthesis. Topic number 19. Okay, this is the same problem as topic number 18. So if you didn't look at topic 18 yet, make sure you look at that. But if I get right into topic 19 now, let's start with our domain. That's just our x values. So I'm going to highlight everything on my x-axis that has some line either above or below it. So basically what I have here is everything from -4 to 5. Except this time, it stops. There's a break between there. Okay, so we really only have that stuff. Okay, well, if that's true, then it's everything from -4 to -1, which I have shown over here. -4 to -1 is shown there. And then on this side, we have everything from 1 to 5, and I showed that right here. And then I had to use the union because it's like an OR problem. So it's basically everything over here is good, or everything over here is good. So it's kind of like an OR problem. And I use closed brackets for this one because it has 2 open circles. I used a parenthesis there and then a closed bracket down here as well. Let's talk about the y values quick. The y values, if I draw this out, I see my my lowest point is there. If I go all the way up to my highest point, it's up there. And yeah, this is included. That has a lower highest point and a higher lowest point. Like it's not the same as on the other side, is what I mean. So that's okay. We only have to worry. We have to worry about like just one of them. So this one here, I guess I don't know. Maybe I'm explaining it too much, but everything from -3 to 4 is going to be included in that range. This one we really didn't even need to look at because it's smaller than the other one. Topic number 20. The graph of the function f is shown below. Find the function evaluated at 0. So we call that function f of 0. We're finding f of 0. That's how you would say it. F of 0. Function evaluated at 0, or function of 0. Basically, the other way that you could read this, though, is if x equals 0, then what is y? So if the 0 is in the parentheses, it's asking you basically to plug in 0 for x and figure out what y is. Or in this case, we have a graph. We can figure out exactly what that is. Where is x going to be evaluated at 0? Basically, it's asking anywhere on this line, because this line is where x equals 0. That's actually the line x equals 0. Where am I touching it? I'm touching it down at -4. So I would write my final answer as f evaluated at 0, or f of 0, equals -4. Okay, topic number 21. Now we're doing two different things. This portion right here is exactly the same as what we did on topic number 20. So we can actually go through this one first. F of -3, or f evaluated at -3. This is what we're plugging in for x. I have it written here as well. It says find y when x equals -3. So to do that, where is x at -3? It's going to be anywhere on this line. Where do we see it? You see it up here. That point is -3, 4. So when x equals -3, I would write it as function evaluated at -3 equals 4. For the second one, for the other one, function of x evaluated, or I'm sorry, it's not evaluated at -2. Function of x equals 2 this time. F of x equals 2. So basically this one is going to be read a little bit different. This one says find x when y equals -2. So now we're doing the y. So we're just switching it up a little bit. If our y equals -2, where would that be located? Our y at -2 would be anywhere along the -2 line. Ooh, I'm going to try to redo that here because I really want you to see what I'm doing. Anywhere on this line. Now, where is it touching that -2? Well, it's touching it here. It's also touching it over there. It says only find one value, though, so you basically get to pick whichever one you want. So if y equals 2, what's x going to be? X could either be -1 or -4. I'll just put -4 for now. So I would show it like this. I don't actually know how Alex is going to want you to write that in there. I think maybe it'll just ask for you to fill in the blank. You'll put in a -4, but I'll write it like this. The function evaluated at -4 equals -2. The x value goes in here. The y value goes back there. The computer's being a little slow. Okay, moving on to topic number 22. Topic number 22 is probably the easiest way to do this one is probably through elimination, which is something I think you guys have done in Algebra 2, plenty of. So that's what I chose to do on this one. It's giving us two equations. And it looks like it's going to be pretty easy to use elimination on them. The one thing that we need to know is that if it gives you two equations, there is only one possible solution. There is no case on this problem where you should be circling more than one yes, like there's more than one that'll work. There's not, because two lines, whenever they cross, they can only cross at one point. They can't cross twice. You can't have yes twice then. They only can cross once. So with my elimination here, I realized that I can't add or subtract these two equations without changing them first. So as you can see in green there, I've got them written. And then in blue, I said, okay, well, if I multiply the entire top equation by 3 and the entire bottom equation by 4, I can end up getting the same thing in my x values. And then I can just subtract them and get rid of that variable, or the x variable, I guess. So that's what I did. I multiplied 3 all the way through right here to all three parts. Then I multiplied 4 all the way through. I got these two equations, and I noticed that these two, if I subtracted them, I added that symbol later. It wasn't a negative 12. I added that to subtract, or I put that there so I could show you that I'm subtracting. That would get those to, they would go away. If I subtracted these, it'd be negative 21 minus 8, which is a negative 29y. If I subtract these two, they don't go away. So why did I make, oh yeah, they do go away. I'm sorry, they do go away because it's negative 24 minus negative 24. That's the same thing as negative 24 plus 24. So I get 0. And I divided by negative 29 on both sides, and I got y equals 0. Then I already had a hunch that it was going to be this one, just because I can see that y is 0, but I'm not really sure what my x value is yet until I plug it back in. And I just plugged it back into the original equation. So I plugged a 0 in for that y, and I solved for x, and I got negative 2, which means this is the one and only solution, meaning I don't have to plug this in or plug this in or plug that in. I know for sure that those aren't going to work. There's only one possible answer for this question. So don't be putting yes twice. Topic number 23, it says graph the system below and write its solution. So right now we have equal signs, and we are going to be finding the solution, basically saying we're going to find where these two lines cross. So that's going to be this. I know I've already got them graphed for you. I'm going to show you how I graphed them. Well, I guess it's not that big of a deal. We've graphed these before. So if I'm graphing this one, I'm getting rid of my x, and my y-intercept was at negative 4. That's this right here. If I get rid of my y by plugging in a 0 for it, it'd be negative 2 times what equals negative 4. That's going to be a positive 2. That's that right there. The other one is in slope-intercept form, and I'm certain that you guys can do that one. I graphed that one out by hand. All right. So I don't remember what I had shown over here. Oh yeah, those are my two equations. Okay, perfect. That's for solving this. That's what that was for. At that point, I just look for my where do they cross, and it's at 2, 0. My final answer is 2, 0. Topic number 24. Use substitution to solve the system. Substitution, if I only use substitution when you have a variable by itself. Now, it could be the x by itself, it could be the y by itself. It doesn't really matter, but I know I'm using substitution here because I have a variable by itself, which means I'm going to take that, all of that stuff, which is equal to x, and I'm going to take it and I'm going to plug it in for x. As you can see, that's what I did up here, and in blue, that's what I plugged in. Give you a second now. I'll give you a second to look at that. Make sure you pause. Make sure you understand what's happening here, what I'm plugging in and how I'm doing it. In blue, you can see I just plugged it in. The green is that first equation. That green is that whole thing minus the x. I just plugged it in. Then I distribute. I solve, and I get y equals negative 4. I'm not done, though, because solving the system, that's only part of it. Y equals negative 4 is only a part of it. I take that negative 4, and I plug it into either of the equations. You can plug it into either one. I definitely am going to choose the bottom one, though, because if I plug it in here, plug in a negative 4 for that, it would just be like I have down here. 3 times negative 4 plus 17, which equals 5. So the other part would be 5. Topic number 25. I used elimination on this one too. They were both in standard form, so all I had to do was add these together. I'm adding them together because we had a positive 2 and a negative 2, and those would cancel out if I add them. So I added them together. I got 7y equals 21. Solved for y, got y equals 3. Took that 3, and I plugged it in for the top one, I guess. You can choose either one, but I chose the top one. My work for that is shown right there. Plugged it in, plugged in the 3. That blue 3 right there is me substituting it. Solve for x. My solution is negative 10, 3. Solve the following system of equations. Again, it's substitution. Topic 26 must not be any different than topic 25. If it is, the only difference that I could maybe tell, maybe I didn't get a good example here, is you might have to multiply the entire equation first. I didn't have to here, so I didn't do it. But let's say that two things did not, like I couldn't get rid of something. I could multiply the entire equation by another number. I did that before. If you're having questions with that, on which topic? Oh, looks like topic number 22. So go back and listen to topic number 22 if you're a little confused on what I'm talking about here. Otherwise, this is pretty similar to topic number 25, so I would check that one out as well. Topic number 27. For each ordered pair, xy determine whether it is a solution to the inequality 4x minus 6y is greater than negative 18. You're going to have to do this 4 times. I only did it once because I think it's pretty simple. All you have to do is plug in these numbers for this equation. And you can see with my colors here, I plugged in 8 and 5 in blue, and then the equation is in green there. After I started to solve it, you got to be careful. If you're multiplying or dividing by negatives, you're going to have to flip your sign. But I got 2 is greater than negative 18. That's a true statement, so I put yes. That's it for topic number 27. You do that 3 more times and you've got one of those problems done. Okay, topic number 28. We're getting a little bit more intense with the difficulty here. It wants us to graph the inequality on the coordinate plane. I have 3 steps written down. I expect you to have these written down as well. Step number 1, graph the line as if there was an equal sign. For example, x equals negative 4. Now, when I graph it, I'm going to do a dashed line because we have an inequality without an equal sign. That's one of the main rules we have to do. That's our step number 2 here. A dashed line is what you use for, I shouldn't have done that because now they look like equal signs. The inequalities without equal signs use dashed lines. Solid lines for the ones that do have an equal sign. So I did a dashed line here. I set the line at x equals negative 4. And then the last step here is we got to figure out which side we're shading. We have to shade because it's an inequality. How do I figure out if we're going to shade it? I plug in any random number that I want. Typically, I like plugging in the origin, or 0, 0. If I plug in 0, 0 for this, we only have an x value that would work here, but 0 is greater than negative 4. I would plug in for x. So if we have 0 is greater than negative 4, that is a true statement. If it's true, then we shade the side that 0, 0 is on. So that's why I have this side shaded, because that makes it true. Let's go to another example. Topic 29. If you skipped topic 28, make sure you're watching topic 28. Next, it says draw the inequality. We're going to draw this as if it was just an equal sign in here. We're just going to picture that as an equal sign. If I do that, this is the line that you would get. I'm not going to go over that. Hopefully we know how to graph a linear equation like that now. And then the last step we have to do is we have to plug in a point. So I would plug in 0, 0, like I've been doing. That's what you can see I just did here. I plugged in a 0 for y, I plugged in a 0 for x, and when I solved, I ended up getting 0 is less than or equal to -2. Well, that's just not true. 0 is not less than or equal to -2, so I did not shade the side that 0, 0 is on. I shaded the other side. Graph the solution to the following system of inequalities. Now we've got two inequalities. And as you can see, I've got them circled there. So I've already got them graphed. I just don't have anything shaded yet. If you're not sure how to graph these, you're going to have to go back to topic number 29 or topic number 28, because I'm not going to explain how to graph these here. Just rewind a little bit, and I'll explain it back there. So after I have them graphed, dashed line and solid line, I just got to figure out where I'm shading. Now I'm going to take them one step at a time. So for this one, for this one, if I plug in 0.00, which is located right there, obviously, what I get is 0 is less than or equal to -5, which is not true. So I don't want to shade the side with 0, 0 on it. I'm going to shade this side. I'm going to shade as much of it as I can. If it's you on your paper, I would lightly shade it. Okay, or on Alex, well, you're probably going to have to do it on paper first, because Alex kind of makes it a little tricky. So you might have to just quickly draw it on paper. For the other one, there's my work. I'm also plugging in 0, 0 for it. If I plug in 0, 0, I got 0 is greater than 5. That's not true. So we're not going to shade the side where 0, 0 is located. We're going to shade the other side. So that would look like this. Now it's kind of messy. I don't know if you can tell. But where are there more than one part shaded? Well, everything in here is just blue, and everything in here, everything in there is green. This is the piece where it's multi-shaded. It's shaded with multiple different colors. So everything inside there is true for both inequalities. That's kind of tricky. Let's see if I can just erase everything here. This is the piece where it was shaded for both. So that's the only part that is true. This one is extremely similar. They just have them in a different form now. So this one was in slope-intercept form. This one is going to be in standard form. You've got to know how to graph in standard form for this. So I've already got them graphed. If you want to go back and figure out where I graphed standard form equations, it's earlier in the video. You can watch it. But I've got them graphed already for us. After that, oh wait, actually no, I did change it up. I actually changed them to slope-intercept form. I forgot about that. I changed them to slope-intercept form, made it even easier. It's kind of difficult actually to graph these in standard form. I forgot about that. So I did change them anyway. I did change them to slope-intercept form, made them easier to graph for me. And then at that point, I just plugged in 0, 0. So for the first one, I plugged in 0, 0, and I got 0 is greater than 1, which is not true. So I don't want to shade the blue one. Maybe a better way to do this, other than actually going through and shading, would be to draw little arrows. I want to shade away from 0, 0. So what I can do is I can put a bunch of little arrows pointing this way. That's the side that I want to shade, away from 0, 0. 0, 0 is located right there. For the other one, after I solved for y, graphed it, I got 0 is less than -2 if I plugged in 0.00. That's not true, so we're going to want to shade away from 0, 0 on this one as well. So if that's 0, 0, we're going to shade this way. And you might already be able to tell where we're going to double shade. looks like all arrows are pointing to this section right here. So everything in there will get shaded. That's it for these topics. There's only 31 topics in Unit 2. So good luck with those. If you have any extra questions, make sure you are asking me.